In this problem, we are asked to sketch the cotangent function, the cotangent of 2x plus pi. We will start by looking at the period and phase shift. We know since our cotangent function, cotangent of theta, is given by cosine theta over sine theta, that my domain restrictions are going to occur when sine theta is equal to 0. If I did a quick sketch of sine theta, I would recognize that sine of theta takes on values of 0 at 0, pi, and 2 pi. Therefore, our vertical asymptotes for the cotangent function would also occur at these domain restrictions, 0, pi, and 2 pi. This will help us recognize that the period for cotangent is originally pi units. Therefore, our period of our function that is given would be pi divided by b, which is pi over 2. We would also recognize that our one-cycle interval is going to be between 0 and pi. Solving for x, we would subtract pi, divide by 2, and we would see that a one-cycle interval for our cotangent function would be between negative pi over 2 and 0. This would also give us the locations of the vertical asymptotes. If we looked at our phase shift is given by opposite of c over b. We would see that this phase shift is given by opposite of pi over 2, which is actually the phase shift for the start of the vertical asymptote. We can now sketch. We're going to see every pi over 2 units. We are going to have a phase for cotangent. We know that halfway between that interval, cotangent will take on its x-intercepts. We could also find additional points. We know that halfway between the x-intercept and the vertical asymptotes, it will either reach its max. It will either reach a, which is 1, or minus a, which is negative 1. We know that the cotangent is a decreasing function. Therefore, at negative 3 pi over 4, it's hitting 1, and at negative pi over 4, it's hitting negative 1. Sketching my graph. Oops. Of my cotangent function. If I wanted to state the domain and put the domain or the x-intercepts in general form, first of all, the domain is all real values of x except for these odd multiples of pi over 2. So I don't want x can't be 0, it can't be pi over 2. My next one would be at pi. Therefore, I can write it in general form as n pi over 2 for any integer n. If I want my x-intercepts, I would recognize that my x-intercepts, one x-intercept is at negative pi over 4, then pi over 4, then 3 pi over 4, that I can locate one x-intercept, and then I'm going to add on every pi over 2 units.